For thousands of years, a deep red star has glowed above humanity from the constellation of Orion. Ancient civilizations noticed it long before astronomy existed as a science. Unlike the calmer stars around it, this one seemed restless. Its brightness subtly changed over time, almost as if the star itself were breathing. To some cultures, it symbolized power. To others, it was seen as a warning in the heavens. Even without understanding stellar physics, early skywatchers sensed that this object was different from everything surrounding it. Today, astronomers know that is one of the most extraordinary stars visible from Earth. Located around 640 light-years away, it is a massive red supergiant nearing the end of its life cycle. The scale of the star is almost impossible to imagine. If it replaced our Sun at the center of the solar system, its outer layers could stretch beyond the orbit of Mars and possibly even farther depending on how much the star expands over time. But Betelgeuse is not calm or stable like the Sun. It is swollen, unstable, and constantly changing. Rather than behaving like a solid object, it acts more like a gigantic ocean of burning plasma. Its surface rises and falls in enormous waves of heat and gas, driven by violent energy moving through the star's interior. Because of this instability, Betelgeuse has become one of the most heavily studied stars in the night sky. Observatories on Earth and in space constantly monitor its brightness, temperature, and surface activity. Scientists discovered that its light changes through complicated cycles caused by massive convection currents. Hot material rises upward from deep inside the star, cools near the surface, then sinks again in gigantic loops. Some of these convective regions are so enormous they cover a huge percentage of the star itself. This creates a surface that is never truly motionless. Bright regions appear and disappear while cooler, darker areas drift across the star like storms larger than entire solar systems. Then, in late 2019, something dramatic happened. Betelgeuse suddenly began to fade. Its brightness dropped so noticeably that even casual observers could see the difference in Orion's familiar shape. Around the world, astronomers reacted immediately. Was this finally the beginning of the supernova humanity had waited centuries to witness? Telescopes across the planet turned toward Orion. Infrared observatories, radio telescopes, and space-based instruments began collecting data across multiple wavelengths. For the first time in modern history, the possibility of seeing a nearby supernova within a human lifetime felt frighteningly real. If Betelgeuse had exploded during that period, it would have become one of the greatest astronomical spectacles ever witnessed. The explosion could have rivaled the brightness of the moon, remained visible during daylight, and transformed Earth's night sky for weeks or even months. Yet despite the excitement, later observations revealed something unexpected. The star was not dying yet. Instead, Betelgeuse had expelled a massive cloud of material from its outer atmosphere. As this gas drifted outward, it cooled and formed thick dust that temporarily blocked some of the star's light from Earth's perspective. In other words, the star had partially hidden itself behind its own debris. This event, later called the Great Dimming, revealed something incredibly important about red supergiants. These stars are not smooth glowing spheres. They are chaotic, unstable environments shaped by gravity, fusion, radiation pressure, and violent internal motion. Entire sections of Betelgeuse can rise and collapse like gigantic storms. But unlike storms on Earth, these are powered by nuclear energy generated deep inside the star's core. Inside Betelgeuse, the final stages of stellar evolution are already underway. The hydrogen fuel that once powered the core has long been exhausted. Now the star burns heavier elements in layered shells surrounding the center. Helium, carbon, oxygen, neon, and silicon fusion all occur in different regions as the star struggles to resist its own gravity. In seconds, Betelgeuse could release more energy than the Sun will produce during its entire lifetime. For a brief period, the dying star may shine brighter than nearly every object in the night sky, transforming Orion forever. Following the Great Dimming event, scientists used powerful observatories such as ALMA and the Very Large Telescope to study Betelgeuse in extraordinary detail. The results revealed a star far more complicated than researchers originally imagined. Instead of a smooth glowing surface, Betelgeuse contains enormous hot and cold regions moving constantly across its atmosphere. Massive convective flows transport energy unevenly, causing dramatic fluctuations in brightness over time. Astronomers also confirmed that the star is steadily losing mass. Its outer layers are continuously escaping into space, carrying heavy elements with them. Carbon, oxygen, silicon, and other materials created inside the star are being released into the surrounding interstellar medium. Those same elements will eventually become part of future stars, planets, and possibly even living organisms. In that sense, Betelgeuse is not simply approaching death. It is participating in cosmic creation. The atoms inside Earth, oceans, and human bodies were forged in ancient stars that exploded long before our solar system existed. Betelgeuse is continuing the same cycle that shaped the universe around us. If the star eventually explodes during humanity's technological age, scientists will witness something unprecedented. Neutrino detectors buried deep beneath Earth could sense the first signals from the collapsing core before visible light even arrives. Gravitational wave observatories such as LIGO and Virgo may detect tiny distortions in spacetime produced during the explosion itself. Then telescopes across Earth and space, including the would observe the expanding supernova remnant in real time across multiple wavelengths. It would become one of the greatest scientific opportunities in modern astronomy. But even before that final explosion arrives, Betelgeuse already serves as a remarkable natural laboratory. Because it is relatively close to Earth, astronomers can study the behavior of a dying supergiant star with exceptional detail. Every observation helps scientists improve their understanding of stellar evolution, mass loss, convection, and the events leading up to supernova collapse. Beyond the science, however, Betelgeuse represents something larger. It reminds us that destruction and creation are deeply connected throughout the universe. The same forces tearing the star apart are also generating the ingredients for future worlds. Its unstable light is not simply evidence of death approaching, but proof that transformation is constantly unfolding across the cosmos. Nothing in the universe remains permanent. Stars are born. Stars evolve. Stars collapse. And from their remains, new systems emerge again. For now, Betelgeuse continues shining above Orion's shoulder exactly as it has for centuries, unstable, unpredictable, and alive with change. It may explode tomorrow. Or thousands of years from now. No one can say for certain. But when that moment finally arrives, humanity will witness one of the most extraordinary events ever seen in the night sky. A familiar red star will vanish in a brilliant explosion, scattering the building blocks of future planets and future life across the galaxy. Until then, Betelgeuse remains a glowing reminder that even the brightest objects in the heavens are temporary, part of an endless cosmic cycle of creation, destruction,